Good morning to all. Thank you, Chairman, and all the executive members of Bamboo Society of India. I'm very happy to present this as a privilege received from Bamboo Society of India. So I'm supposed to talk a small work which we have done on converting bamboo to charcoal. So here, this is basically is a field-oriented trial to convert some of the basic waste from small-scale bamboo industries. I think just now you have seen that the very so much of information from the earlier presenter, Dr. Bharati. The present one is only just a small experiment what we have conducted as a project work in Kerala Forest Research Institute when I was there. And we were associated with so many works in bamboo. And especially as I was in wood science, this is connected with the wood technology part of it. And especially meant to use the waste from bamboo industries, small scale bamboo industries. You know, the crooked basal portion and the waste top portion and the whole stems of bamboos unsuitable for structural or other non-structural uses, and bamboo waste from industry or manufacturing units. All these can be converted, the value can be added, and it can be used as a value-added utilization of bamboo waste as bamboo charcoal. The next one, please. See, this bamboo charcoal is not that familiar to the local people. It may be familiar to the industry for power generation and all those things, but the local small-scale people who are producing bamboo products, they are not that much familiar with the bamboo charcoal, especially the place where I work in Kerala. Many people are used for gas, for energy and cooking and all those purposes. But this is also a good opportunity to convert the waste. Otherwise, the waste, I have seen that in all the small scale units, the wastes are dumped without any specific use. And the culture that for this burning or for these boilers and all, local culture is to use coconut shells, or to a little bit larger industries, they use briquettes of wood briquettes or something, wood waste briquettes and all. So there is an opportunity for converting these. Our people should be familiar with the bamboo charcoal. And it has been well reported that bamboo charcoal is a good deodorizer, dehumidifier, and many industrial products can be made with it. So, next one, please. Let us go to the next one. Yeah. Our work was mainly concerned with the previous one. Third slide. Just before that, yeah. See, people generally, especially people connected with the forest areas and all, they make charcoal in the traditional earth pit method. And the earth pit method, of course, it is polluting, but how the traditional people are making charcoal? They are making wood charcoal, and the same technology has been demonstrated for the preparation of charcoal from bamboo with the same people. So the transparencies here shows that the bamboos were cut, and then they were the earth pit has developed, and they are firing the same thing. Of course, it is a skilled art in the sense that the air entry should be controlled. Otherwise, what we are finally we will get otherwise ashes only. So there should be a very good skill to control the air. And the bamboos were stacked, and it is covered with some green leaves and mud, and proper air vents. That doesn't for air entry as well as air exit. There should be holes, and there should be the people to watch this. And after that, after giving the particular burning time, you will be getting charcoal as shown here. Next one. Next, please. Yeah, this is a conventional portable drum kiln method for producing charcoal in the very rural level, where they can transport the drum to one place to another. Especially this is used for very small scale production of charcoal from wood. The same we tried for production of bamboo also, bamboo charcoal also, and it is called a drum kiln method because in Tonga and all this method has been widely in practice. So this is the first preliminary method of this using drums at the local level for production of charcoal. And the same thing, next one. Next, please. Yeah, the same people who near to the forest areas who produce charcoal, they were employed for production of charcoal from their own methods to see that how they are producing and all. So the same type of drum, instead of the Tongan types, here they use the vertical type of production where they use, they cut the lid and pack the bamboo inside. Of course, traditionally they used to produce some timber or offcuts and wood, but they are asked to put some bamboo and the same method what they produce. They fill it with that and they give a fire, and after controlled entry, permitting controlled this air inside that. Now it has been well packed with the lid, and then after a particular time when the digestion is over, we will get the charcoal, and the product is also shown here. So this is the country method where our local people, how they are making charcoal from this portable drum method. Next one. So this is a method. Next one, this one is this is the same one. Another method. This is a traditional method where they produce this wood, distillate from wood. Say for example, this in some temples and all they require teak wood distillate for some religious purpose and all. So the same method, they produce teak wood distillate by external heating. They put these wood pieces inside a small mud pot or earthen pot, and they properly cover it, and an external fire is given, and so that a little bit higher charcoal will be the final product. So the same people who are skilled in producing this distillate, they were asked to produce charcoal using bamboo to see that how the country method, the variation in method affects the quality of charcoal, and whether there is any benefit in indirect heating and things like that. It is not a self-firing method, whereas the drum method shown earlier were all self-firing method. So here we get charcoal. Here also we get charcoal, and it has been well documented, shown in the transparencies. The properties and other type of things we will come in the next time. Next slide. So this is the way the indigenous earthen pot method, the charcoal can be obtained. So we are not suggesting this type of methods for any industries, but try to experiment how the indigenous methods affects the quality, whether that can be extrapolated to at a higher scale and things like that. So can we go to the next one? Yeah. So here the inference is that the yield and quality of bamboo charcoal were found to differ significantly between the methods. That means the two type of methods, what we are employed is self-firing pit and drum methods produced lower quality charcoal. Self-firing methods yielding lower quality charcoals, whereas the externally heated method, for example, the earthen pot we just tried gave a lower yield but higher quality. And bamboo charcoal, what we produced, has found high ash content in the rate of 7.5% and has alkaline in nature with a pH of about 8.9 to 9.7. So it is alkaline and the ash content is little bit higher. And with the high volatile, that is about 12 to 24%, and low fixed carbon content, that is about 71 to 78%, suitable for domestic users was obtained from the self-firing method, that is the peat and portable drum method, with low yield of around 26%. So this shows that the country with a volatile content little bit higher. So shall we go to the next? Next one, please. Next. Yeah. That is about 9%. And high fixed carbon bamboo charcoal suitable for industrial uses when employed in indirect heating. Say, for example, the earthen pot method. When we employed that, we got bamboo with a low volatile content and high fixed carbon content, which is actually required for to be charcoal. Say, when we talk about charcoal, generally either charcoal or the coconut charcoal. Coconut shell charcoal is the traditional. Coconut shell charcoal is of high value. It is very dense and it has been used for industrial purposes. And some of the wood charcoal are used for some lower grade purpose utilization, like for pyrolytic that type of things, and for some small products also. So what inference is that when we are using the country methods, we are getting products with a little bit of higher volatile content, which is required for fuel purpose or something like that. We require it should be burnable. So that means a little bit of higher volatile contents are necessary for use for domestic use. Whereas for industrial purpose, there is more fixed carbon and less volatiles. So that means theoretically it shows that self-firing methods are suitable for producing charcoal for domestic purpose with a little bit higher volatile content, which requires a little bit higher volatile content, and the indirect heating method for producing charcoal of little bit higher property suitable for industrial applications. So the next one, please. Next slide. Yeah. So as a continuation of the same investigation, we tried a double drum. We fabricated a double drum retort type of thing. This is called a retort. So where to increase the output, we use a double drum method, and bamboo were loaded in the drum, and external firing has been given. And we got and of course the air entry is permitted, controlled, and the temperature has been recorded. We produce the charcoal in different levels of temperature, and for controlling the temperature and knowing the temperature, we connected with a thermometer, a pyrometer type of thermometer, which can be viewed and measured from a distance. So this is the method for producing or to increase the yield, a little bit of a modification from the traditional method what we employed in the in the field. So here also we got charcoal. Next one, please. Yeah. Again, some more investigations were continued to see that this drum retort. It is a in chemistry we call some certain type of heating. This type of what you call the destructive distillation type of concept. We call it as a retort. So this is a drum is converted into a retort type of thing where we can collect the pyroligneous gases producing, and the pyroligneous gas can be used for external heating, so that you can save some fuel wood when you are using external heating. The pyroligneous gas can be collected. So this is one way, and the same system, same retort was provided with the facilities for cooling the pyroligneous gas with water and all, and collecting the pyroligneous gas converted into liquid. That is, you can see a small mud pot placed near that backside of that drum where that cooled distillate can be collected. So here there are two options. One is to use that gases directly without cooling for heating itself so that the firewood can be saved. Another thing is you cool that gases and collect the tar, and tar can be used for some other purpose. So here the advantage of what we observed is charcoal with the low volatile content and high fixed carbon content suitable for industrial use is obtained. And the thing is that what we observed is that when we use at a low temperature, because there also we connected with a pyrometer and we recorded the temperature and all. When we produce at low temperature, as mentioned earlier, we get a product with a little higher volatile content and yield will be little bit high. And when we produce with the higher temperature, we are getting product with the lower volatile content and higher fixed carbon content. So like that. So we have the option that whether we want charcoal for domestic purpose or we want charcoal for industrial purpose. And another observation what we got is, we can go to the next one. The next one, yeah. When the design of the retort was improved for recovering the distillate by condensation, bamboo charcoal with still higher quality was achieved. That is a volatile content about 9%, fixed carbon content of about 84.2%, ash content of about 6.7%, and up to 33% yield. And here also it was alkaline with a mean pH of around 9.7 and a mean iodine value of about 256 milligram per gram, which is of course low. So the condensing the pyroligneous vapor and separating it could yield industrial grade product. That means when we used the pyroligneous char, that pyroligneous gas for heating, and when we use the pyroligneous gas condensed and collected, we found that the pyroligneous gas, when we are condensing and collecting, the quality of charcoal is much better. So what is the low carbonization temperature resulted in higher yield with the high volatile content and low fixed carbon content. So again, a close-up view of the retort, the single drum retort system with facilities for condensing the gas or collecting the gas or collecting the distillate is shown here. This is appropriate to the rural context. So this is what we obtained. So can we go to the next one? Next one, please. Yeah. So now we just tried a trial production of bamboo charcoal in an industrial pilot scale carbonizing plant. So the basic one, we tried it at rural level, forest level, then transportable kiln, then comes a little bit of science in it. Then now we are trying to make use of some industrial pilot scale plants available with some of the carbon industries. So a refractory brick insulated stationary self-firing type carbonization kiln of about 1.3 meter diameter, 1.5 meter height, capable of maintaining a drafted 20 millimeter water column, available with Messrs. Indo-German Carbons, Kochi, Kerala, was used for this trial. And we have employed a 0.4 ton of bamboo in this small kiln, and we used it as in the form of half splits, and self-firing method is employed because the kiln is meant for that type of thing, and maintaining a temperature of about 850 degrees centigrade for 2 hours with a regulated air of at about 35 degrees centigrade at atmospheric pressure within a carbonization time of about 3 hours, gave 31% yield on moisture-free basis with a volatile content of 15%, ash of 7.8%, and fixed carbon content of about 77% with a pH of 9.8 and iodine value of 309 milligram per gram. So this indicates that bamboo charcoal suitable for industrial use can be obtained even by using a small kiln. So the rural level as well as the lab or small scale field technical studies were transferred to a small industrial scale, And shall we go to the next one? Next, this is only just to show us that the charcoal they are taking out from the kiln. Next one, please. Next slide, please. Yeah. So here we are using, now the thing is that all the self-firing methods as well as those what we are using in many of the times batch processes. When these drum methods or pit methods or earlier even using external heating, or all these methods are batch processes. Batch process, when just like cooking, when you start cooking, you will be firing the stove. And in all batch process, in the beginning, there will be some smoke spread at ground level, which is always not that much encouraging, or people will not like it. So the batch process is always have the complaint of producing some smoke at the beginning as well as at the end. Similar to the same thing that when we are using our country stoves for burning or cooking something in our kitchen, the smoke will be there in the beginning and smoke will be there in the end. So when we are closing the stove means and starting it after some time, again the smoke problem will be there. So batch process suffers this type of ground level smoke spread affecting the health and environmental issues and all. So the solution is only a continuous process rather than a batch process. A continuous process is planned. And industries, this may be okay. But for rural or small scale people, batch process cannot be. This continuous process is difficult, or techno-economically that may not be viable. So we thought that there are those small cluster type of enterprises which are there prevailing or existing in the small country level enterprises. If they have a common place and they can have a small carbonizing plant which can produce continuously, the issue of this the smoke problem can be controlled, as well as this some sort of chimney type of approach can be employed, as well as some sort of modern this pollution control devices can be attached in the flow process, so that it will become more industrially acceptable, the charcoal production. So such type of thing was not there in the in practice, and we designed a small vertical continuous carbonization kiln as what is shown here, so that it can produce charcoal continuously. So as the traditional methods are polluting, there is a need to go for a pollution-free carbonizing plants for the production of charcoal of desired quality for industrial use is well justified by the comparatively moderate yield, 31.1 to 33.1% from retorts and 29.2 to 30.8% from industrial pilot plant tested, and the quality low volatile content in the tune of 9 to 15%. So what we obtained is the charcoal obtained from these pilot continuous plants are also good or equally good for industrial use. So the issue is that the inherent poor hardness of bamboo charcoal may be a limiting factor for its use for granular active carbon suitable for industrial use. This type of carbonizer is produced for in a project associated with using these coconut shells for producing charcoal of good grade suitable for production of activated carbon, granular carbon, production of charcoal without pollution. So what we found that when we employed this bamboo charcoal, the product is the hardness of the product, that is an inherent quality which was not that good as compared to other charcoal origins like wood or coconut shells. So this is a limiting factor for its use in granular active carbon, where the hardness is very important. So that is only the limiting factor. And the next one, let us go to the next slide. Next one, please. Yeah, this is just a drawing of the vertical carbonizer, which we have shown just in the earlier slide. And this is the engineering drawing is given. And an upscaled version was installed in the Central Plantation Crops Research Institute at Kasaragod, Kerala, with the help of support from ICAR. And this plant is a little bit bigger than the earlier one. it is also the carbonizing plant, but only at the top a pre-dryer is fitted, so that if the moisture content of the material is little bit higher in the rainy season and all, there can be a pre-dryer, and charcoal can be produced employing this vertical carbonizing continuous plant. And here also pollution is not a big problem because it is a continuous process. And we have been tested it, and the product quality has been tested and found that it is satisfying the Indian standards for industrial use. Next one. Yeah. Next one. Yeah, some of the references, the earlier works what we have done is written here, and all these detailed or the full texts are available with the website of Kerala Forest Research Institute, where we used to publish all the reports and as well as all the scientific papers in our website. So the full text is available. Anybody can download it and use it. And the uses of, next one. The uses of charcoal, especially bamboo charcoal, has been, literature says that it is a very good deodorizer. It can absorb these odors, and it can filter air. So in your fridge, in your freezer, in your bedroom and bathroom, in your gymnasium bags, hockey equipments and bags, toothware, kitchen, car park area, pet area, renovation area, garbage, compost pail and diaper pail, etc. We can place these deodorizer packets so that you can have the area without smell, as well as it absorbs toxic chemical substances for commercial and industrial applications. It is used in air filters, and various products in the convenient form were made with the bamboo charcoal. But not very much familiar in India. But now they are even because of the good brand ambassadorship that we are getting in the bamboo sector. Whatever products they make from bamboo, now they are projecting it as a product of bamboo. And you might have noticed that even in paste and all, it has been bamboo charcoal paste, toothpaste with bamboo charcoal like that. So this bamboo charcoal has a good scope. And just like now bamboo is, rather than 100% science, it is become just like a religion. So always religion is connected with beliefs and illogical things also. It is when we are having something connected with the beliefs. So this caused a lot of confusions about and a lot of misinterpretations. And one product is interpreted in terms of another product. Say, for example, when I looked into these websites or when I looked into this internet and all, many times the bamboo charcoal is misinterpreted in terms of activator carbon. Some sites says that bamboo charcoal is an activator carbon. Bamboo charcoal is not at all activator carbon. Activator carbon is entirely different. It is not a synonym of charcoal. And the important thing is that when charcoal is of course a raw material for active carbon, and the surface property is the most important thing as far as the charcoal or activator carbon is concerned. And the activator carbon, the surface area of activator carbon is for 1 gram of activator or 1 spoon of activator carbon has the surface area of a school ground or has the surface area of a playground, football ground. That means 1 gram has the surface area of about 1 square kilometer. So what is happening? The conversion of charcoal into activator carbon, the porosity is increased. We are increasing the porosity by controlled admission of steam and the temperature. Otherwise, we are activating it with using chemicals such as calcium chloride or calcium chloride or sometimes phosphoric acid and things like that, where the initial raw material is powder and not this charcoal. Say in the activator carbon, powder activator carbon, maybe it is for that bamboo may be more suitable, for which initial material is a dust. So converting charcoal and again dusting and again making it into activated will be a great loss in terms of product as well as energy and all. So generally the powder activator carbons are produced from chemically activated powder activator carbons are produced from sawdust. So if bamboo sawdust can be used for production of activator carbon, powder carbon, whereas this is bamboo, solid bamboos, or the waste from small scale rural industries or small cottage units and all can be converted into solid bamboo charcoal, which can be used for these deodorizing and air filtration type of things, and various products can also be made with them, which will be a value added utilization and better utilization of these waste products. And only thing, we should not confuse charcoal with activated carbon. Bamboo can be used for production of powder activated carbon, but it may not be appropriate for using as granular carbon because its quality, hardness may not be appropriate, or when we compare with the other activated solid carbons or granular carbons from coconut shell or wood. So this is what I have to say here. There is a scope for producing bamboo charcoal in India at the smaller scale level for livelihood programs or for livelihood enterprises and things like that, where our marginalized bamboo dependents will get an additional income. So this is what I have to say. I am very much thankful to the organizers, especially the Bamboo Society of India, Sri Sundar Naik IFS, as well as Sri Ranjanadan, who is constantly interacting with us, promoting, and they are so much sincere about their attempts. And I wish all the good works for the future also, and very happy to interact with you. So if there is any doubts or if there is any more clarifications required, the papers are available, the raw material, the references are available from ICFRE website. And also I am here in Bangalore. Anybody wanted, I have noted my address, this phone number as well as email address there. We can have interactions. And this is what I have to say. Thank you for the privilege given to me. I consider it as an honor given to me on the day of this International Bamboo Day. So thank you for all.
Dr. Dhamodaran ji.
Yes, sir.
I think always we used to contact you at the last moment when 1 or 2 days are left out. It is because of the certain domestic problems with us. So please bear with us, and we need your cooperation, guidance, and help for organizing similar programs in future also. Now I request our Secretary cum Treasurer, Sri Ranganatha Krishnan, to propose vote of thanks. Very good.
Thank you, sir. Thank you, Chairman, sir.
Thank you.
Dhamodaran, always a pleasure to hear from you. And on behalf of, it was really an informative session. On behalf of entire BSI, on this wonderful day, I'd like to extend my heartfelt thanks, sincere thanks, and wish you all the very best, sir. Yeah.
Thank you, Ranganath. I will be here always to support and collaborate with you.
Pleasure, sir.
You can
We're all one bamboo family. We have to coexist and strategize for the next leap, sir. Thank you very much.
Thank you.